Why is the Atlantic Ocean current collapsing, and can it cause global cooling? Published by Severe Weather Europe. The latest data and new studies reveal that the Gulf Stream has been weakening and steadily declining over the past decades. Weather in the United States and Europe depends strongly on this ocean current, so it's important to understand the ongoing changes and what they mean for our weather now and in the near future. There is growing awareness that the Gulf Stream and the overall Atlantic circulation are nearing a critical point of collapse. The data shows that the largest factor for its weakening is likely an increased influx of freshwater from the melting Arctic and Greenland ice. North Atlantic Ocean circulation. The North Atlantic Ocean currents are a part of a large system called EUMETSAT. This powerful ocean system brings warmer waters up from the Gulf of Mexico into the North Atlantic Ocean, hence also the name, Gulf Stream. It extends all the way up along the eastern coast of the United States, where it starts to turn towards northern Europe. The image below shows a general outline of the Atlantic Ocean current and where it flows across the North Atlantic. It does not actually flow in such a nice straight line, but as you will see, it is very complex and full of motion and dynamics. This strong current of warm water influences the climate of Florida directly. Compared to other southeastern states, it keeps temperatures in Florida warmer in the winter and cooler in the summer. This is just one example of the direct impact this current has on the United States. Since the Gulf Stream also extends towards Europe, it helps to warm the Western European countries, having a major impact on the regional climate and also impacting northern parts of the continent. We can actually see this current if we look at the ocean temperatures and the surface currents. Below is the latest ocean current analysis that reveals the Gulf Stream. It starts its way in the Gulf of Mexico, turning around Florida, flowing up along the east coast of the United States, and then out into the North Atlantic. No ocean current ever flows in a straight line, as seen in many graphics. It is actually very complex, with a lot of dynamics and swirling across the North Atlantic. It has a lot of smaller swirls of water, both warm and cold, very similar to the jet stream in the atmosphere. As ocean currents slow down, there is a theory that the Gulf Stream might shut down at some point, making the movie, The Day After Tomorrow, a reality. In that famous movie, the North Atlantic Ocean circulation has completely shut down, pushing the world into a new ice age. The movie is not scientifically accurate, as these global changes do not happen in just a few days. But the main idea behind the movie is not far from the truth, as you will see. Going directly to the point, the graphic below shows the strength of the EUMETSAT over the past centuries. Of course, these reconstructions are based on proxy data, such as coral data, ocean sediments, and land-based data. But they all show the same story of what is going on with the Gulf Stream. The most important takeaway is that we can see an intense weakening of the EUMETSAT in at least the past 200 to 300 years. This reconstructed data agrees with the modern instrument observations, which gives it good confidence in the historical reconstruction part. Ocean temperatures are most often used to determine the strength of the Gulf Stream and the entire North Atlantic current circulation. The image below shows the North Atlantic Ocean divided into two areas. On the eastern coast of the United States, we have the warm Gulf Stream area. But in the subpolar North Atlantic, we have the blue area, where the Gulf Stream releases its heat and sinks down into the depths. The graphs on the left show temperature progression over time. You can see that the Gulf Stream area is warming while the North Atlantic is actually cooling over time. The relative difference between these two areas is typically used as an estimate of the strength of the EUMETSAT. We produced a graph showing the relative difference between these two areas. It is nicely seen that there has been a slow but consistent downward trend since at least the 1900s. Especially in the past 40 years, we can see a stronger negative difference in these two areas, indicating a likely further weakening of the EUMETSAT. The data basis for this graph comes from NOAA's ERS-STV5 dataset. It is a combination of observations and reconstructions, taking all the available data and modern techniques to reconstruct the sea surface temperatures back to 1854. Of course, the data is not 100% accurate that far back, but it is proven to work very well for modern periods, giving confidence also for the historical ages. Now, the next graphics are even more interesting. First, we have a computer model simulation. It shows what would happen if the EUMETSAT were to weaken. We can see the warming of the Gulf Stream region along the east coast of the United States and cooling in the North Atlantic. The second image below shows the actual ocean temperature trends over time. It looks practically the same as the model simulation of a weakening AMOC. This supports the fact that the AMOC is indeed losing strength, perhaps even faster than first anticipated. This temperature signature of the warm Gulf Stream area and cold North Atlantic is one of the strongest indicators of the AMOC weakening. Instrumental direct observations have also objectively confirmed that the North Atlantic circulation is indeed on the decline. The idea is that as the Gulf Stream weakens, it cannot transport the warmer waters toward the north as effectively. That means warmer waters start to pile up along the east coast of the United States. As a result, the North Atlantic starts to cool down because it is not receiving as much salty warm water anymore. We produced another graph, this time for the warm Gulf Stream part along the northeastern coast of the United States. It shows the strong temperature increase in this region, especially in the past 60 years. This is consistent with the theory and simulations of the AMOC weakening, as the warmer waters are stalling along the east coast of the United States instead of being transported to the north. There is more than one reason why the AMOC is weakening. In the movie The Day After Tomorrow, melting Arctic and Greenland ice introduced lots of fresh water into the North Atlantic, creating a strong imbalance in the ocean current. As you will now see, that is actually one thing that the movie probably got right. Meltwater in the North Atlantic. Freshwater reduces the salinity of the North Atlantic. That makes the surface water less dense, and less heavy, so it can't sink properly down to the depths. Because the ocean current can't sink as fast, it's causing a traffic jam, slowing down the entire current. Below, you can see a graphic that shows the sea surface salinity over a larger area. You can nicely see the salty waters coming towards the North Atlantic with the Gulf Stream. But we can also see a lot of fresher waters in the Arctic Ocean, which flows down into the North Atlantic and the North Pacific. Looking below, we have the salinity anomaly for the last decade, and a bit deeper, at around 50 meters, 164 feet. You can see that the North Atlantic is fresher than normal. This strongly indicates that there is currently more fresh water in the North Atlantic than is normally expected. The story is the same at 200 meters, 656 feet, depth. We can see a large part of the subpolar North Atlantic fresher than normal. That is directly in the area where the Gulf Stream starts to sink down into the depths, which indicates an inflow of fresher water. Data from ECMWF ORAS 5. Below is a graph showing the salinity anomaly at 200 meters, 656 feet, depth in the August-October period. This covers the latter warm season, with the highest rate of sea ice melt. It quite obviously shows that more freshwater is arriving in the North Atlantic, with the trends showing a decrease in salinity over the far North Atlantic. This freshening of the North Atlantic can also be traced to the Arctic sea ice anomalies. The graph below by Zach Labe actually shows the Arctic sea ice volume anomaly since 1979. We can see a gradual reduction of sea ice volume, meaning a stronger melt rate, and several millions of cubic kilometers of sea ice now melted away. The long-term salinity trends below are very obvious. We can see a stable salinity decrease in the North Atlantic, indicating the influx of freshwater over time. This is very similar in trend to the Arctic sea ice melting trends just above. Looking at depths, we can see the strong reduced salinity trend reaching deeper down in the North Atlantic. Stronger freshening is seen in the surface layers, most affected by the fresher waters from the Arctic and Greenland. This is one thing that the movie, The Day After Tomorrow, got somewhat right if we ignore the time scale. But are we now facing a new ice age? The short answer is no. But we are not yet at a full collapse and shutdown of the Gulf Stream. Global cooling after the Gulf Stream collapse. Using state-of-the-art computer systems, we can create a global simulation of what will happen once AMOC reaches the breaking point. Below is the end result, which shows the temperature compared to a world with active currents. You can see that the entire northern hemisphere is experiencing a colder anomaly as temperatures drop. And that is just the beginning. Strong climatic changes are to occur, with very different pressure patterns and precipitation distribution. Winters will become more severe in the United States and Europe. This would partially counter the continuing warming, but it would introduce further severe destabilization of the already changing climate system. It does not mean a new ice age just yet, but the global weather changes can be quite substantial. Another separate simulation also produced a very similar result: a temperature drop across much of the northern hemisphere. The southern hemisphere is shown as warmer because, with the currents slowed down, less heat is transported to the northern hemisphere. In the image below from another simulation, we can also see the precipitation patterns. It shows less precipitation over much of the northern hemisphere, except for the southern United States. There, we can see an increase in precipitation under a collapsed ocean circulation. Combined with the seasonal temperature changes, this would mean colder winters across much of the northern hemisphere, with increased snowfall into the deep south of the United States. Europe would likely see less precipitation but still experience colder temperatures than normal overall. So, while we do not see a new ice age start immediately after the collapse of the Gulf Stream system, the global weather changes are significant. But we do not need a full collapse of the EUMETSAT to change the weather. Slowing the Gulf Stream means more water piling up on the east coast of the United States, which is dangerous for storm surges. For Europe, it can mean a change in the track and strength of low-pressure systems coming in from the North Atlantic. Of course, this is not something that will happen overnight, as these changes can take years, decades, or even centuries. But we do know for a fact that the EUMETSAT is in decline. Based on the amount of freshwater induced by the melting ice, we will likely be seeing climate effects still within our lifetime. But what can happen almost overnight are strong storms and hurricanes. And the Gulf Stream and the EUMETSAT play an important role in these events, especially for the United States, as we will now examine. The United States weather from the Gulf Stream. As the water in the far North Atlantic is not sinking as fast anymore, due to it being fresher, it slows down the ocean transport system. Because the ocean flow is slowing down, the warmer water from the Gulf Stream has nowhere to go, and stalls, like in a traffic jam. But we do not need a full collapse of ocean circulation to change the weather. As the Gulf Stream slows down, more water will accumulate on the east coast of the United States. This means less warm water is actively transported to the North Atlantic as it stalls just off the east coast of the United States. The image below shows the sea surface height trends as the Gulf Stream slows down. The height of the Gulf Stream increases as it slows down and piles up. This increases the storm surge potential and provides more fuel for the storms. For Europe, it can mean a change in the track and strength of low-pressure systems coming in from the North Atlantic. A somewhat recent example of this process was the infamous Hurricane Sandy in 2012. Below is a NOAA satellite image of Hurricane Sandy as it was sitting over the warm Gulf Stream, using it to power up before landfall in the United States and bringing along a devastating storm surge. These effects are connected to changes in ocean currents and have an immediate effect. So, it's not just the cooling or a new ice age that can result from these changes. We already feel the immediate effects of the changes in ocean currents. Based on the amount of freshwater induced by the melting ice, we will likely be seeing climate effects still within our lifetime. It is actually hard to argue that some are not happening already, but it is not easy to filter them out in a chaotic system like the global climate. Check out the new study on the Gulf Stream collapse by Nicholas Bors, from the Potsdam Institute for Climate Impact Research.